So we're going to start off the year talking about numbers and patterns and what kind of things we can do with numbers like add, subtract, multiply, divide. We also have fractions, decimals, and all that great stuff. So some of this stuff you should be familiar with already. So let's talk about prime factorization. And before we get into that, I want to just kind of go back to the basics of how numbers are categorized. So a number is either considered odd or an even. So, yeah, I know you're like, oh, I already know that, but let's just review it anyway. So an odd number is a number that cannot be divisible by 2. So we know we have 3, 5, 7, and 9, and so forth. I'm not going to go on forever because I have other things to do. So if it's not an odd number, it's an even number. And that is a number that is divisible by 2, such as 2, 4, 6, 8. Who do we appreciate? Just kidding. But again, I could go on forever to infinity, but we're not going to do that. So it's either odd or it's even. And then each number has what we call factors. And a factor are the numbers you multiply together to get another number. So let's just say I have the number 4. Okay, so what can I multiply together to get 4? Well, 1 times 4. I can also multiply 2 times 2. So the factors of 4 are 1, 2, and 4. So those are what I can multiply together to get 4. So each number has factors. Now, a number, in addition to being odd or even, is going to be prime, or what we call composite, and that's going to be our next definition. But let's take a look at a prime number. And just as a clue, they're going to be odd numbers with the exception of 2. So it's a number that can be divided evenly, and when we talk about evenly, we mean like with no remainder. So it can be divided evenly only by 1 and itself. So one of the examples from Danica, the book that I have in the classroom, is think monkeys. Monkeys are pretty primitive. Oh, look, the prime. Okay, so very simple, where it's only divisible by 1 and itself. So we have 2. That's the only even prime. And we have 3. 4 is not even. I showed you that already. Could be another number could be divided into 4. 5, 6. Oh, I know I can divide by 2 and 3. And then let's go to the next one. 7. 8 is not a prime. 9 is not a prime. 10 is not a prime. And then 11. And again, we could keep going on, but we have other things to do. One of the things that I do want to recognize right now are these 4 numbers right here. I like to call these our bench. These are kind of going to be the numbers that we refer to. So whenever I say what are your bench numbers, it's going to be 2, 3, 5, 7. And you'll understand that a little later. So even or an odd number. And then they're all going to have factors. What can I multiply to get to that particular number? And then a prime number, again, is only divisible by 1 in itself. And if it's not prime, it's going to be composite. So it can be divided evenly by numbers other than 1 or itself. So we have some examples. If you look over here, we have some examples. Oh, you can see that those are some of the numbers that I have here. We already talked about 4 having factors, because I can divide it by 2. 6 is a composite number. I can divide it by 2. I can divide it by 3. And we have 8. I can divide that by 2. I can divide that by 4. And then 9 can be divided by 3, and so forth. Again, we could go on, but we have much better things to do. So we're learning how we're going to categorize different numbers, because everybody wants a special name. So let's look at a real life example. And this is something that you would do if you were trying to figure out how you can break groups, what different size groups you could make. So let's take a look at this one. A science class of 30 students is on a field trip at the zoo. The teacher wants to break the class into smaller groups of the same size to observe the reptiles. That's basically so not everybody's running together. If we can break, like we usually break our classes into groups of 4, groups of 5, depending on how many students there are. So it's asking us to find all possible group sizes by writing all the factors of 30. Now remember, a factor is what times what gives me 30. Well, the one we know right off the bat, our freebie, 1 times 30. So I like that one. The next one, let's go, I can do 2 times 15. I'm going to go 3 times 10. And I'm looking to see, because I can't split a person in half, so I'm looking to see which groups or what size groups I can make them into evenly. 30 can't be divided by 4 evenly. 5. I can have 5 groups of 6, or I could have 6 groups of 5. Okay, so notice that these are pretty much the same, they're just reversed around. So I could have 1 group of 30, 2 groups of 15, 3 groups of 10, 5 groups of 6, or 6 groups of 5. But if I want to know what the factors are, I would just list them. So here's all the different groups I can make. But let's just say you just wanted to know what times what gives you 30. So I would list them out as 1, 2, because I'm going to order them. Mathematicians want like things to be in order. So you're going to want to list it in order from least to greatest. So 1, 2, 3, 5, 6, 10, 15, and 30. And some other students, oh yeah, you make your rainbow and you're like 1 times 30. Maybe that sounds familiar to you. 1 times 30 is 30, 2 times 15 is 30, 3 times 10 is 30, 5 times 6 is 30. So whatever, if that memory from 5th grade or earlier on comes to mind, go ahead and use that strategy that you have already learned. So one of the things, a strategy that some students showed me is they used to make a T-chart. And then I was like, oh, we can make that better. We can call it a tuxedo shirt. So, because when you make a T, where's my cursor? Okay. So I'm like, oh, that kind of looks like a tuxedo shirt. And if I was to overlay that to this shirt, you'll see what I'm talking about right here. Okay. So I want to list all the factors of 35. And I'm going to go ahead and use the T-chart or tuxedo shirt. You could think if you're looking for factors, you want to be fancy with your factors. So always, always, always write down your freebie. 1 times 35. This isn't an even number, so I can't divide it by 2. And 3 times some number. I don't think that goes into it evenly. 4 doesn't work. 5. 5 times 7. 6 doesn't go into it evenly. 7 goes into it evenly. But notice I've already repeated. So once you repeat, you don't actually need to include that in your tuxedo shirt. So what you're going to do is you're going to draw this line. Okay. And here are your factors. 1, 5, 7, 35. Okay, so notice I'm nice and organized because mathematicians want to be organized. And I just basically went around here. So 1, 5, 7, 35. And if you wanted to do your rainbow, you could say 1 times 35 is 35, 5 times 7, 35. Alright, let's make a T-chart of our tuxedo shirt. Fancy tuxedo shirt for our factors. Again, always write down your freebie. 1 times 32. You're like, boom, I'm done. But it's not all the factors. Okay, you need all the factors. So you go to 2. 2 times what gives me 32? Now let's say that you couldn't figure that out in your head, which is okay. we got to do that old school. So don't be lazy. 2 goes into 3 one time. 1, 2, 16. So 2 times 16. And then I'll go 3. Now 3 doesn't go into it evenly. And here's a trick to find out if a number goes into it evenly. Notice my digits are 3 and a 2. So I'm going to add 3 plus 2 equals 5. 5 is not divisible by 3 evenly. So 3 is not a factor. And then let's go to 4. So hopefully you remember your multiplication tables. So if I did 4 times 6, that's 24. 4 times 7 is 28. Oh, 4 times 8 is 32. And then you go to 5, doesn't work. 6 doesn't work. 7 doesn't work. 8. Oh, notice I'm repeating again, so I'm not going to list that 8 again. I don't want to duplicate. So you make your little tuxedo shirt, and if you're going to list them out, you list them in order from least to greatest. So it's 1, 2, 4, 8, 16, and 32. So those are listing the factors, all of the factors of the number. Oh, but I have another one out there. Let me go ahead and erase all of this. So 23. Again, let's make a T-chart. Put our freebie down. Well, what do I notice about this? It's not an even number, so it's odd. And I want to see, so I go through what numbers. So it doesn't fit the 3 category because 2 plus 3 is 5. That doesn't work. So it's a prime number. So the only factors are going to be 1 and 23. And that's all you would do. List it. 1 and 23. Those are your prime numbers. Alright, now your prime factorization. And I know you're like, oh, it's a factor tree. Hopefully you will remember that. So, to factor a whole number as a product, and remember product is our key word for multiplication. Okay, you'll either see it with this little X or you'll see this little dot for multiplication. Okay, so to factor, prime factorization means to factor a whole number, not necessarily an odd or even, but to factor a whole number as a product of prime numbers. So again, going back to Danica's example, is I like to say, how many monkeys are going to be in your tree? And you want your tree to have all the monkeys at the bottom. Okay, and so your trees could look like this and break off like that. Okay, so all of your prime factorization, kind of going backwards here, could look like that. And with all your monkeys finally at the bottom. And I'll give you an example of that. So, factor trees, okay, again, your monkey trees, you're looking for your prime numbers. So that's kind of what gets people into confusion, is to use a factor tree, you're actually getting all the way down to the primes. So this is where those bench numbers come into play. And I'll show you what I mean by that. Okay, so here we go, 44. So I'm going to make my tree. And I know 1 times 44, but I'm not going to write that. That's just, I don't want to do that. So it's an extra work. So I'm going to go to 2. That's my first number on my bench. 2 times what gives me 44? So that's going to be 2 times, let's say 22. 2 times 22. Now this is already a prime number, so I'm going to go ahead and circle it. He's already a monkey. Okay. And then 22, I can break that down into 2 times 11. Oh, those are all prime numbers. So my prime factorization is going to equal 2 times 2 times 11. Another way that we could write that is 2 squared times 11. And that's kind of just a little fancier way to kind of make it as small as possible, because 2 squared is the same as 2 times 2. So 2 times 2 is 4, 4 times 11, 44. And these are all prime numbers, so it meets the definition of prime factorization. Let's take a look at one other number. So again, I'm not going to do 1 times 54, because that's just an extra step. So I'm going to go to my